Hello everybody, welcome. Welcome to my talk about Keynterceptor. So first off, who am I? I'm Niels van Dijkhuizen. I work as a CSERT analyst for a large CSERT, and so this is a hobby project of mine, which I would like to share with you. So in my spare time, I'm a demo scener, make music with electronic devices, and I have a hobby in electronics, officially embedded systems engineer, but day-to-day work I do more of the IT security essentially. So today we're going to start with existing USB human input device attacks. I'm going to tell you what's wrong with them, because they're not optimal. There are some available protections. We will cover those, and we will have a look at how to bypass these, and by showing my proof of concept. And the whole reason for this presentation, the whole reason why I wanted to look at this topic is, well, we have to raise some awareness on USB devices. I mean, we've seen the Rubber Ducky and such. Well, I guess you all know why we should have a look at this. So let's start. A brief history. So the earliest mention of USB keyloggers that I could find was from 2005. If anybody knows an older product, please let me know. Then there's a gap. We jump to 2010, and we see the first keystroke injectors, essentially. So in the same year, Iron Geek, also known as Adrian Crenshaw, created his FUD, funny name, essentially a TNC that does keystroke injection, and Hack 5 brings the Rubber Ducky to the market. The year after, Adrian combines his earlier keylogger research with the Rubber Ducky kind of attack, the keystroke injector. Then in 2014, we get the interesting research done by Karsten Knoll and co, the bad USB. So reprogramming the controllers on USB devices, mainly mass storage devices, to introduce different kind of functionality like network interfaces and such. And Semi Camcar shows his USB drive-by, which essentially is a keystroke injector with mouse emulation as well. And then we have some research by David Kierzonski. I'm really bad with that name, sorry. Probably pronounced it right, not right. USB 2, essentially two devices with a intermediate PC in between that controls the protocol stuff, also primarily focusing on the human input device. And last year we've seen the Bash Bunny essentially emulating all kind of devices, and well, having the opportunity to program it freely makes it a versatile hacker tool. And the Cactus wireless keystroke injector. What they all have in common is that they are pretty in your face. I mean, if you sit behind a machine, plug it in, and you see weird stuff happening, you will probably shut your computer, throw out the device, and call the help desk or something. So you either need to have an unlocked machine, unattended computer, or be very good in social engineering to make it a success. Next to that, many payloads require internet access, for example, to set up a reverse shell. And let's have a look at the things that could block this kind of attacks. This is what I found out. We've got some hardware protectors. The US Good from Robert Fisk is an interesting thing. USB device, a USB dongle that sits in between your mass storage device or keyboard and your host. It is interesting because it protects against some of the attacks. So it was meant to block the bad USB kind of attacks. So if I plug in a USB stick that later on reconfigures itself as a different device, it will detect it. So essentially, this device see re-enumeration. So that's the process where, so normally if you plug in a USB device in a host, it does, we do USB enumeration to see which devices are there, and if it presents itself while connected as a different device, that gets blocked. So in order to bypass this, we have to have the functionality within the device without reconfiguring. Then there's USB proxy from Dominic Spill. It's a bit faster than the USG. The USG is very slow. It's really like less than USB 1 speeds. So I think it's even noticeable if you connect a keyboard. It's even noticeable when you type. So it's really too slow. Then on the software side of things, we have a USB guard from Daniel Kopecek from Red Hat. He created an extension to UDEV, on Linux, of course, to have a user interface where you can allow or block a connected USB device. So as soon as I plug in a keyboard or a mass storage device, I will get a pop-up on my screen that says, "Hey, is this a good device or not?" And like a personal firewall, you can choose whether it's okay or not. Good Dog is a non-mass storage kind of class, USB class protector on Windows. And then there's Beamgun, which also blocks rogue USB network adapters and hits, but it doesn't work in all cases. So finally, we have the USB keyboard guard that warns you when a new hit is connected. So it will block all keystrokes until you click the button. It's allowed. We have Duck Hunt. It's another kind of thing. It's not USB filtering, class filtering device, piece of software, but a superhuman typing detector. So if you really type fast, there's probably something going on. There are exceptions though. If you use a YubiKey or something like that, it's meant to type things fast. And we have GRSec, GR security patches for the Linux kernel, which allows to block devices that are being plugged into your computer after it has been booted. So my idea about the implant is that we would have a human input device attack that works with locked machines, and that can bypass the described protection mechanisms. And in order to be, for it to be feasible to really being used in real-world scenarios, I thought it would be good to have it cheap, small, and covered in operations. So the design requirements I had was the implant should be in line with the machine. So it should really be an implant inside of a keyboard, and it should have some notice of time, and you'll see later on why that is. And to spice it up a bit, it would be nice to have some other channel, communication channel to over the air, for example, to communicate with it and have some control over it. You might recognize this thingy from the NSA catalog. It's not going to be that small. essentially not because it's a proof of concept. So what I came up with is essentially a host adapter that lets you connect a USB device to that, a computer. So essentially a microcontroller with USB device support so that it can relay stuff. A real-time clock that has a battery-backed notion of time. A communications module, in my case a 433 megahertz UART. And an EEPROM to store config stuff, so non-volatile RAM. This is what I came up with. It's a bit big, it's a bit bulky, but well, it's proof of concept, right? And I could ditch the EEPROM because the teensy controller has an option for it. But you get the idea. The host, USB host, the microcontroller, the brains, the communications module with a antenna, the clock, battery-backed clock, and the configuration built into a printed case. So first off, how to bypass the USB policy kind of protections. So let's take USB guard from Daniel Kopacek as a reference. You could simply clone USB descriptors. It's not very hard. So this proof of concept doesn't clone it lively. That would be really convenient. But if you know, for example, if you want to infiltrate in a company, they probably have some brand being used primarily, and you could easily clone that kind of device. It's just a matter of going to the shop, clone that descriptor, and you can present yourself as that device. It's a bit of a, I had a bit of tweaking time on it. So first off, it showed itself as a full USB speed device, but had to downgrade it to a low speed device. And once you're really done, so the way USB guard works, it just dumps your complete USB descriptor table and make a hash of it. So once you miss one bit, you already get caught by the program. So I literally make a copy of it. And then to bypass the superhuman typing detection kind of daemons, we just introduce some random delays. So I use the Arduino environment because it's really easy and simple to quickly prototype stuff. To create a new kind of, so you saw that it was typed in 1 second. That's the superhuman typing that I meant. I created a new kind of USB profile, essentially, called Evil Keyboard, that just clones the descriptor table, the clone descriptor tables and do the slow typing. So here we see that, it looks like human typing, so it will not be triggering superhuman typing detections. So duck hunt, for example. So when I started, I thought, let's measure power, because we cannot go beyond the limitations. So normally for a keyboard, it would be 100 milliamps max, if you look at the specifications. So I stay with under the radar. It's 100 milliamps max, but this device it's crap. It's not very accurate. So I did some remeasuring. This has gives us better insight in how it's actually, how the power consumption is doing. So the plain keyboard is very low. Then we go to around 30 milliamps for a keyboard with bright LEDs on. Keynterceptor is even using more. If we have 3 LEDs on the keyboard, we're still under the power consumption of the Keynterceptor. But if we have the Keynterceptor and the keyboard, we clearly go up high. So essentially, we could detect an implant. So if we look at the cost of this proof of concept of the Keynterceptor, it's really affordable. So we can check that. So use cases. Well, we can control the keyboard over the air because we have a communications channel. We can do auto login with captured credentials because it's in line with the keyboard and the computer. We can do keystroke injections after activity with a chosen time. So let's say we know that the office is open until 6 o'clock in the evening, and after that it may be activated. We can block user input with an RF radio frequency kill switch, for example for takedown. Well, enter your scenario here. I chose to make it a bit more complicated and spice it up with a companion. So what I did is I took a Dell power adapter and I inserted a NanoPi with a again with a 433 megahertz communications with the UARTs essentially, a UMTS or 4G dongle to have a connection uplink, and a power block. This allows me to do the following. Here we have the target, let's say an office building. One places the Keynterceptor in between the keyboard and the computer, or have a keyboard prepared that's inside the keyboard itself. We have the power adapter that can communicate with this device. The power adapter can also communicate with a VPN server. The VPN server is the hub, so to say, where I can connect with a laptop or with a mobile phone to essentially reach out to the machine, to the companion. And well, let's just show that with a little video to give you an impression. Oh shit, sorry. Demo gods are hard to please. So let's retry this. Yeah. Sorry for that, guys. Shit. Sorry. Oh, come on, man. So who in the audience here has a form of protection on USB? Any hands? Nobody? Come on. This is annoying. Good thing. Ja. Ja, ik ben uit mijn presentatie. Sorry, there it goes. Finally. So, we are at Evil Corp. Placing the companion. So first powering it up without plugging it into the network. Then we place the Keynterceptor in between the keyboard and the host. And you'll notice that as soon as I connect it to the endpoint, it will start blinking. The LED will indicate that it's requiring a configuration, and we'll send the configuration through the companion to the Keynterceptor. So I connect to the OpenVPN connection from my phone over 4G. I open the application, the interface of the Keynterceptor, and we see that the ETH0 is not defined yet. Or I mean, we didn't get a DHCP lease, and that's because we didn't have a link yet. So we connected to the network. Wait a while, we get an IP address, and we get to choose either a timed attack frame, or we choose a demo to make it activate more quickly, so that we don't have to wait. So now it's configured. The LED is not blinking anymore. This means that the Keynterceptor is configured. It now has the IP address of the companion, so it will reach out at some point, as you will see later on, to the companion. And now we're good to leave. So at another location, we hook up the computer over 4G with a OpenVPN connection. Once we're done, we have the ability to log into the companion and start a listener. We'll start a listener on the left side, and we'll start the keystroke sniffer on the right side, because the keystrokes are sent over 433 MHz to the companion. So the listener is called Lavietti, and now we'll just wait for a connection, and on this side we wait for the user to sit behind its desk. As you can see, we see the user typing near real time, complete with timestamps, so we get track of what the user is doing. The user locks his machine, goes to the toilet or something, returns to its desk, type in his password. The Keynterceptor detects the key combination to unlock the machine, so it knows at some point what the password is of the user. So now that we have captured the credentials, it goes into a state that it waits for the user to be gone. It automatically logs in and will start a payload. The typing is slow, and it's on purpose because we're pretty sure that the user is gone. Gone to home or something. Here we reuse the IP address that we got from the Keynterceptor, because this is just the first stage, and the second stage is at the actual command and control is done from the companion, of course. Okay, Windows style hidden, so it's gone. Log off, and the computer. If the user returns, it will not be very clear that the machine is compromised. This one says it's done. It got a signal that the machine is popped. We see the password is top secret, and we got a shell here, and we can do whatever we want with the machine on the network. And that essentially is the demo of the proof of concept. So, well, you all know the post-exploitation stuff, I guess, so that's not very interesting at this point. Okay. So, new mitigations. How to block this kind of attack? Well, essentially, I think the cleanest and the easiest way to do this is to have a multi-factor authentication each time you unlock your machine or log into your machine. It's a bit of a pain, of course. A user will get bugged by these extra questions, but I think it might be worth doing it. It depends on the situation. If you're in a high security facility, I think it's a good idea. The other one is profiling, monitoring power consumption per device. But then again, hardware support is a bit problematic. Most laptops don't have a way to see how many currents are drawn from a USB port. So just to see whether that could work, I created a little proof concept for that as well. So here we have another microcontroller in a little box that just allows me to plug in a device that is relayed to the machine, and it just monitors the current that goes through the ports. Here we have a monitoring link, and what we can do, we can define our maximum milliamperage per kind of device we have. So here we have the Packard Bell of Hewlett Packard Elite keyboard that I also used for the HIT cloning, and USB guard shows that there's a new device which is USB policy-wise allowed, and the USB PowerMon that I created that communicates with the little box shows that everything is okay. And if I introduce the Keynterceptor in between the keyboard and that port, it will be bad because we use more than 13 milliamps more than we would expect. So then the machine got blocked, and that's showed off with the amber colored LED. That works, but it's not very feasible for a laptop, of course. But you could build in something like that into a PC, full-blown PC or something. Is it feasible? I think so. It costs some development time, some lines of code, some euros to develop it, but I think it's very feasible. There's some future work. We can see if it's. I can fit it in real hardware. I'm pretty confident about that. Automatic descriptor cloning will be doable as well, even maybe with a FPGA. And the encryption of the covert over-the-air communications is also quite easy. So I think it's very feasible, and we should be thinking of ways to mitigate. And I think the operating systems having some form of multi-factor, that would be a good starting point, I guess. Yes. Are there any questions?
Given the time, I would say, Niels, are you still downstairs for the rest of the day?
Yeah, so I brought my hardware, so I can give a full demo. You can see the hardware. I can screw it open if you want, or whatever. I will be in the corner next to the Hack in the Box booth. So if you have questions, you can come up to me as well. So thank you for your attention, and sorry for the technical delay.